Today I am going to present experiment number 4, Uniform Quantization and Pulse Code Modulation or PCM. The main objective of this experiment is to understand how a continuous or analog signal can be converted into a digital signal using quantization and PCM encoding. We also study how the number of bits affect quantization error and SQNR. First we generated a sinusoidal signal and normalize its amplitude between -1 and +1. Then we apply uniform quantization to this signal. In uniform quantization, the entire amplitude range is divided into a fixed number of equally spaced levels. The number of levels is given by L is equal to 2n, where n is number of bits. In this experiment, we test 2, 3, 4, 6, 8 bits. For example, with 3 bits, we get to the 3 or 8 quantization level. With 8 bits, we get 2056 levels. Therefore, increasing the number of bits give us better resolution. After quantization, every sample is assigned a quantizer index. This index is then converted into an n-bit binary PCM code word. For example, with 3 bits, the index from 0 to 7 represented by binary values 00 to 111. We also calculate the quantization error, which is difference between the original signal and quantization signal. Means square error or MSE is calculated using the average of square quantization errors. A low MSE means the quantized signal is close to the original signal. Another important parameter is SQNR or signal to quantization noise ratio. It tells us how much stronger the original signal is compared with quantization noise. The theoretical SQNR for the whole scale sinusoidal signal is approximately 6.02n plus 1.76 dB. Therefore, when we increase the number of the bits, the SQNR would increase and the quantization error should decrease. The visualization we generate four main results. First, we compare the original and quantize waveform. Second, we plot the staircase characteristics of the uniform quantizer. Third, we show quantization error waveform and its histograph. Finally, we plot square versus the number of bits and compare the practical result with the theoretical values. From the experiment, we observed that increasing the bit resolution provide more quantization level, reduce the quantization step size, decrease the error, and improve. To conclude the experiment, the basic principle of converting an analog signal into a digital representation using uniform quantization and PCM, it also clearly shows the relationship between bit resolution, quantization error, and signal quality. Thank you. And this is my code. This is the values, and this is the graph. And this is my GitHub where I put the Python code. And this is my project. Thank you, sir.